Today we're going to take a look at how to graph the sine and the cosine functions, and after that we're going to look at how to graph transformations of each of those functions. So we're going to start with our parent function, and the first thing that I want to point out to you is that we have the function set up as y equals sine of x. Now make sure that you understand that x actually represents theta. The input for all of the trig functions is an angle, and the output is a ratio. So for example, for the sine function, the output is opposite over hypotenuse, so that's the y value. Be careful that you're not thinking about points on the unit circle when you see the x and the y value. A little bit confusing, so I wanted to hopefully clarify that before we get started. Now, as we're getting started, to find those y values, those outputs, those ratios, I start by drawing a unit circle. And we're going to think about where the sine value is at a maximum. And for the unit circle, the maximum value is 1, the minimum value is -1, and then there's the middle value of 0. Those are the key points on the graph, so those are the only ones that we're going to find. And for the sine function, they occur at 0, pi over 2, pi, 3 pi over 2, and 2 pi. So kind of those quarter turns for the unit circle. We could plot all of the functions, including the pi over 6, pi over 4, pi over 3, but that would give us a lot of points and it wouldn't give us any additional information that the key points don't already give us. Alright, starting at 0 radians, the ordered pair is 1, 0, and remembering that the sine is the y value on the unit circle, the sine of 0 radians is 0. Up at pi over 2, the ordered pair is 0, 1. So at pi over 2, at an input, the sine of pi over 2 is 1. Over at pi, we have -1, 0. Sine value is back to 0. Down at 3 pi over 2, we have 0, -1. So the sine value is down to -1. And of course, back over to 2 pi is where we started, so we have a sine value of 0. Rotating in the opposite direction, sine of -pi over 2 is -1. Sine of -pi is 0. Sine of -3 pi over 2 is 1. And the full rotation back around, sine of -2 pi is 0. So again, notice the maximum and minimum values are -1 and 1, and that midpoint is 0. So we're going to graph this. Our y values go from -1 to 1, and then we have the x values, or the input, the radian, the rotation, the angle rotations of pi over 2, pi, 3 pi over 2, and 2 pi, and of course those same values in the negative direction. And then we simply plot our points. So at 0 radians, the sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and sine of 2 pi is back to 0. Now remember, we could keep rotating around the unit circle, so we will put arrows on our sine function. And we go in the opposite direction for the negatives. And notice the sine function is a curve, not straight lines, so don't connect those points with sharp straight lines like an absolute value function. We have a nice wavy curve for our sine, and we'll see for our cosine function as well. Now we're going to take a look at identifying some of the key information about the sine function. The domain, because it's an angle rotation and we can rotate in a negative direction, the domain is all real numbers. The range, because the sine is a ratio, thinking about setting up that right triangle opposite over hypotenuse. The hypotenuse is the longest side in the right triangle, so the sine ratio will always be between -1 and 1. So our range is -1 less than or equal to y, less than or equal to 1. The period of the function is how long that it takes to come back to where it started. It completes one full rotation of the unit circle. So the period is 2 pi. And we can see that in the graph because from 0 to 2 pi, the graph went up, back to 0, down to -1, and back up to 0 where it started, and it's heading up again. If you look at the negative direction, it does the opposite, but it makes one full wave between 0 and negative 2 pi as well. The amplitude is kind of half the height of the graph. So the height of the graph is from negative 1 all the way up to 1. Half that, so kind of starting at the x-axis up to 1, the amplitude of the parent function is 1.